Thank you, Tia. Can everybody hear me okay? Tia, can you hear me okay? All right, very good. Well, welcome everyone this morning. Obviously being September 1st, which is quite crazy that it's already September, but today our goal is to make things very interactive and engaging and as best we can. As we all know, with the virtual platform that we're all kind of switching to throughout COVID-19, it's definitely a challenge to integrate a lot of the hands-on components. And that's something that today we're going to illustrate some hands-on activities you guys can do at home or at your after-school program, however you guys are transitioning this fall. But to start, my name is Bill, like Tia mentioned, not William, but officially on the taxes, it is William. I've been working in the after-school fields for around 20 years. Started out actually working for a company here in Boise that provided curriculum around Lego education kits and connects kits. And in doing that, I would go out and train teachers and after school providers all around the country on how to integrate STEM into their curriculum and their program. And while doing that, towards the end of my time at the company I noticed that there was a huge gap. There's a lot of resources out there that weren't necessarily titled STEM at the time, but my goal was to find things that would engage students from all grades, all walks of life, and let them explore STEM in a whole new way. So starting out with inexpensive resources. When I first started STEMfinity out of my house, I was able to round up 250 different kits. And over the years, we've expanded to around 12,000 different STEM education resources. And what that does, it allows us to customize solutions based on your needs. So we are, when you call in or email us, we can basically modify the material we have and create a solution based on your grade level, number of students, et cetera. So we're somewhat a clearinghouse for STEM resources. But as you can see on here, I got the title Most Influential in STEM by NAA years ago, about 3 years ago. And it's something that I've been a huge advocate for that. And it's great to see the movement grow, gaining popularity. And now it's more of the STEAM than it is STEM. I think we need to include the arts in there. But that's why STEMfinity is STEM and beyond. So we cover the arts already. But STEMfinity, it's meant to be a resource for you guys all to find and explore and look out. But over the years too, we've worked with the gentleman named Jason Lindsey, aka Mr. Science, who's done our STEM 101 professional development for many years. But today he's going to be showing some different activities. But Jason, do you mind talking more about yourself?
Oh, yes. Hey, how is everyone? I hope you are safe and well as we continue to battle COVID-19. I know it's tough and it's rough, but I continue to think about each and every one of you as some of you are heading back to school in person, virtually, maybe a hybrid program, whatever it might be. You continue to be in my thoughts because I know it's a big battle and I know it's pretty rough and tough. At the end of the day, though, it turns out that we still got to get kids excited about science. So that's exactly what I do through a business called Hooked on Science. I partner with my friend Bill and STEMfinity, an outstanding organization, to get America, kids, teachers, parents, everyone excited about science. So my science degree is in meteorology. Anybody know what kind of scientist I am at all? See if there's any comments that pop up. It looks like there's a few. I'm going to step over here to see. Weather, yes, I am a weather, what they might call a weather person. We don't say weatherman anymore because that's very disrespectful to females. We call them meteorologists. Bottom line is I predict the weather or attempt to predict the weather by using my knowledge of science. I do that in a place called Lexington, Kentucky, and Evansville, Indiana are the two stations or the two TV markets that I work in. And when I'm not doing that, and whenever COVID's not a big problem, I visit several hundred schools across America, from California to New York and everywhere in between. Last year, I partnered with some folks called Bayer, and we did science and learned a little farming aspect to science over in Germany and Brazil as well, working with kids that are making a difference when it comes to farming in their countries overall. But that's just a little bit about me. I love to do science. We're going to do some cool science today, and I love to visit classrooms whenever we don't have this big, gigantic, mean, ugly virus that continues to impact us in so many ways.
Yes, well, thank you, Jason. And something Jason doesn't tend to mention, but he has been on the NBC Today show, is it 16 or 17 times?
Somewhere in there, national television,
Somewhere.
from Fox and Friends to RFD TV to the Today Show, the list goes on, all kinds of fun experiments at the national level.
Yes, well, and we have a little video clip here I can share with everybody, and hopefully the sound comes through okay for everyone here. So here we go. Sorry, choppy internet.
Hey, Bill.
Yeah?
This is Tia. I don't think anyone can hear the sound on the video,
All right.
but I'm wondering at some point throughout the training if maybe you can put the link to that video
Yes.
in the chat box and then people can watch it after the training.
Yes, we can do that for sure.
Cool.
So this video, it is available on hookedonscience.org, and so we'll be talking about that more later on. But as you can see, though, these mini trips, spinning Kathy Lee around, John Cena. He let me go on the set with him 2 marches ago, and Harry Connick Jr. was on there. So it's just a great experience to share science at a national level, which Jason's done over and over. And he has used to do large assemblies for schools, probably 2 to 3 times a week, if not more. Jason, is it 3 times a week? How much were you doing assemblies?
I was in a typically I was in a school in person 5 days a week,
5 days a
sometimes
week?
up to 2 to 3.
Yeah, so he bouncing around between meteorology and then I was obviously large national networks, but then doing things inside malls, etc. But he's very much a huge advocate for getting kids excited about science and STEM. And so that's why we've partnered over the years. And today, let me kind of walk through some of the, hold on here. It's all freezing up on me. All right, so we do have some questions because this is enough about Jason and I. So we really want to get to know all of you a little bit more. So we put together some different polls on these questions that Tia should be able to share with you guys. So the first question is, who offers or do you offer STEM activities for your students? Yes or no?
Can you all see the poll on the screen?
Can we get thumbs up if you can see it? Okay. If you guys don't mind going through those real quick, this will help me kind of describe some different things as we go through it. But the first one, do you offer STEAM activities for your students? I'm trying to see if I'm not seeing any results yet here. Oh, because you have to do the whole end poll. So I'll give you guys about a minute here to fill those out, and then we'll walk through the polls. And a lot of these I know are changing every week. We're adapting accordingly, whether it's virtually or hands-on. But we're seeing a kind of a blend of hands-on and virtual currently with a lot of the schools and after-school programs. So it's like 26 of 43. We're getting there. 27 of 43. So once we get past about 35, I'll go through these. Good old technology. Okay, so looks like an overwhelming majority do offer STEAM activities. And for those that have not, we do have some different solutions, such as free STEM activities to get you started. Kind of take the fear away of teaching STEM, which kind of is intimidating at first, but getting past that initial fear with some free activities is a great way to get started. Question number 2 is, do you use hands-on or virtual online activities to address STEAM? And it looks like I mentioned before, it's a blended approach, a variety of hands-on with virtual. One thing we have done for a lot of school districts primarily in the spring and going into the summer, we provide a lot of inexpensive resources that they'd hand out at lunchtime. A lot of them are Title I schools that would order a lot of inexpensive kits and distribute those, so then they have a hands-on component to go with the virtual side of teaching. So it's like a majority of them are a blend. And then for STEAM programming, looks like science is the overwhelming majority. Of course, technology is integrated within. And so what you'll notice is with STEAM, typically they're interwoven. You're going to have an activity that may focus on technology or science, but as you're teaching the science, it's also integrating the engineering or the math with that. And so we very much want to illustrate how an activity can get that blended approach as you're teaching it. Looks like robotics is about half of you. 3D printing is a technology that is going to be a little challenging now with everyone primarily going virtual. Computer science, that's something you can do more now. There's a lot of virtual robotic programs, one called Coders or Coders D, Cogmation, etc., that are out there. And drone technology, the great thing about drones now, a lot of them are programmable, so you can do the coding and programming with them as well. So not too many drones or 3D printing, but obviously the core STEAM areas have been a big influence, a big area of activities. And so the best approach would be, looks like hands-on, kind of the blended approach as well. So combining the virtual with hands-on, we feel as well as a good way to go. I can't view the chat screen, but what are some of the other things that you guys are doing? So what works, doesn't work? Can someone type in on the chat as to what they feel are some other options between what works and what doesn't work? So can you read off some of those for me? I'm not sure if they're coming up in chat or not.
I only see one in the chat. Someone was confused on one of the questions, but if anyone has anything to add for Bill, please write it in the chat box right now.
Okay. Because we have 5 that are on the other side, so I just want to see what those might be. And as you guys write those in, I'm continue on. So have you noticed the effectiveness of hands-on learning with your students? And it looks like an overwhelming have. And that's a big part of what today's presentation is going to be covering is the hands-on and not us lecturing or presenting to you. We'd rather you guys get the hands-on components because it is something that students retain a lot more of the information by doing versus reading it or by just looking at it. And do you have any of those? Sorry, I can't see the chat on
Sure.
my screen.
Stephen from Club for Boys said coding. Samantha saying students are excited to participate with hands-on learning, STEAM activities. Stephen's also saying Minecraft building challenges. Stephanie saying hands-on is always the best for her students. Same with Benjamin, hands-on is always engaging. Alexandra saying various hands-on learning that the students can take home to do with their families. And then Maria is saying EV3 robotics. Okay, some Lego education, which by the way, Lego education is sponsoring this presentation. So we'll get into our partnership with them and some of the different STEAM solutions we have with Lego education. And then question number 6, how do you suggest we make hands-on STEAM activities accessible for students? So affordability is key, offering inexpensive resources for them.
and then the blended approach of virtual combined with hands-on. Looks like it's worked out very well for everyone. So I'm going to end the poll. Let's see here. Share results. All right, so that's what we have in there. Tia, do you mind removing the poll from the screen? And we'll continue on here. So one thing today, speaking of LEGO Education, we will be doing a giveaway. How it's set up though is the LEGO Education kit that we're gonna be giving away is the Spike Prime set, which is a new middle school resource. And so it is something that we'll be putting the code or the URL in the chat bar. So make sure you get a chance to enter in. If you've already entered in before, within this presentation, you can enter in a second time. So you get 2 entries into the chance to win. So we have LEGO Education Spike Prime set, which I'll be diving into deeper here in a little bit. But it is available for after school and summer programming. And it goes between the We Do and the EV3 set, which is more high school. So it's a great kind of middle of the road science or STEAM set. So we're giving that away. And let's see here. And then for Jason, if you mind talking about the Hooked on Science lab book and what all comes with there.
Yes, sir. Basically, what I did was create a lab book that's virtual, that's Google Classroom friendly, that basically covers physical science for K through 5th grade. It's really focused on a reading level for 3rd, 4th, and 5th grade. And basically, it's everything they need to do with 10 science experiments, nonfiction reading, and videos to learn science virtually. We hit topics like energy, force, motion, matter, waves, all NGSS, next generation science standards. Basically, you will get a guide. The videos are already embedded in the actual guide for the students. And then there's an answer key as well. There's a website that you go to for more resources like games as you are teaching this virtually. The student downloads it in the Google Classroom. They type in their answers, and then they can save it and submit it to you. All the experiments are based on the scientific method, basically, and there is room there for them, each experiment sheet for them to collect data to come to a conclusion, all that good stuff, and all the experiments use ingredients from around the house. So that will be sent to a lucky winner. Yeah,
and so make sure you get entered in. And Tia, do you mind? I'm sure you probably already shared the link, but share that with the crew, and then they can sign up as we go through this. So it's going to be the 2 different kits. We have the LEGO Education Spike Prime set right here, and comes with a bunch of different activities for ages 10 and up. But it'd be good for you all to start out for your middle school programs, and you can see some different components here in the kit right there. So get signed up. All right. Well, let's continue on.
Fill the links in the chat for people to click on and fill out the information.
Perfect. All right. So get entered in. And while you're doing that, I'm going to go dive into more about hands-on learning. So who here, I guess maybe by this raise of hands or thumb up, who has seen this graph before? Bloom's taxonomy. So this graph represents different teaching methods. And so basically at the top, you'll see more of a passive teaching method, which is lecturing, which I've been doing. Reading has about 10% retention. Audiovisual, which is somewhat what the students are getting through Zoom and through the virtual platform, is 20%. A demonstration, which we're going to be doing with Jason here in a little bit, is 30% retention. But the goal in teaching is to get them in the participatory teaching methods. So where they're discussing, the different topics, and the goal is to get them that 75% range, which they're actually doing hands-on and constructing and building different kits, and able to retain more of the information is what they're going through. So they'll, if they do it, they're most likely to learn it and retain that information. But the ultimate goal is to get them where they can actually teach others, which is a 90% retention. And so if they get to that point, if we ever get back to a normal after school program, you can have one student maybe is excelling at that area, and they can then teach the class or help the other students out on how to learn, whether it's coding or how to construct, different, whether it's cardboard construction. We have some different adapters and connectors for that, et cetera. So they can walk them through and do the hands-on with that. So that's a big part of what STEMfinity and Hooked on Science, we focus on the hands-on components of learning and teaching. All right. So STEMulate program. So like I mentioned early on, the goal is to integrate programs that have more of a blended approach to STEM or STEAM. So as you go through, we would typically hand out or have different kits on the table and have you guys building with them and then writing down some different ways you can tie in STEM or science and math at the same time of teaching engineering or technology and science with math, et cetera. So what I'll show you is some different documents we have, which we'll be able to share afterwards in just a minute. But after the presentation, we'll go through, there's a STEM planning worksheet and some different activities or how to select the STEM activities for your after school program. So one thing too that we've done at STEMfinity is we've realized there's a lot of hurdles that you guys face as you go to integrate STEM in your program. And so with that, you'll see that there's everything from insufficient funding. I know a lot of you may have like the 21st Century Community Learning Center funding. There might be state funding. It might be a grant that you have written that you have funding for your STEM programs. But that typically is the first hurdle that a lot of you will face. Second hurdle is the lack of knowledge about existing curriculum. So we at STEMfinity, we spend a lot of time vetting out the different resources you see online. And so instead of you spending hours comparing one robot to the other, we've already evaluated them and understand the best way that they can be integrated in your program and the best grade level, et cetera. So we can help eliminate that step. Lack of professional development in STEM or STEAM. And that's where Jason Lindsey comes in. There's a lot of other free training as well with Click to Science. I know, this training right now, we're trying to provide a lot of it free, but there are some that does cost, but it's more customized to your program there. And then a lack of partnerships available in STEM fields. So a lot of the programs we work with are in very rural areas, and there aren't any scientists or engineers nearby that they can bring in. But for instance, I know majority, the Boost network is in California, and so you do have a lot of large engineering firms and scientists and NASA. There's other organizations around there that you can pull from and try to connect the dots for your students. And so, for instance, like right now we have Jason Lindsey with us, and so he's able to elaborate more on how science, how he's using science every day in his job, but also how it can get other kids excited about science and just kind of show them that connection for them. So make sure we get to that point. And here are the two documents which we'll have available at the end. So there's a STEM planning worksheet, which we'd hand out. This is before we had added the arts in there. So you'll see it just has the STEM areas. But for instance, we'll grab, let's see here, something like this right here. It's a little bit STEAM student set. So something like this, how does it integrate science and math and everything else? And a lot of the curriculum and resources we have will actually have the NGSS alignment within there, so you don't have to worry about that. But the questions we want you to ask are over here. You'll see there's everything from, is the activity safe? There's also now a lot more about cleanliness. So as we're building with different STEAM activities, we want to make sure that we're able to keep them clean and sanitized. So there's different cleaning schedules that you can go through and do, which most have some sort of solution for COVID-19 right now. Is the activity appropriate for the age group? What STEM skills will your youth learn by doing this activity? Does this activity provide opportunities for collaboration? So these are things that you'll want to go through, and this is with Click to Science, which has some free online STEM professional development available. So like I said, these will be available at the end, so you'll be able to go through and utilize those. But today, Jason, who's right there, actually, are you on set, Jason?
I am on a set in Lexington, Kentucky.
All right. So with Jason today, he has 5 pretty exciting activities he's going to go through and do. Maybe more depending on time. But the goal today is like I said, to show you how science and STEAM can be exciting, but how you can integrate the virtual side of it with hands-on, and give you some different solutions that you can work with. So, Jason, if you want to take it over, and we'll go from there.
I have about 30 minutes, is that right? I need to take them to the top of the hour.
Yep, let's do that.
Okay, cool. How is everyone? I hope you are safe and well as we all continue to battle COVID-19. As I'd mentioned a little bit earlier, I continue to think about you as you adventure into a new way of teaching. I say new way, we were kind of forced into it. We always knew on the back burner that virtual was the future. But we all know also that you can't really learn science, hands-on science, the way Bill has been talking to you about for the last few minutes or so, virtually. So there are a few ways that I kind of have evolved and changed and created programs that allow parents as well as teachers and kids to get the best that they can get as we continue to battle COVID-19. Some is better than none. We all know that. So there's some ingredients in front of me, and you're going to notice that they are ingredients from around the house. That's key with this COVID-19 pandemic and teaching science. You got to make sure that you have ingredients that the kids could easily have access to. They already have it in the kitchen. They already have it in the bathroom. They already have it in the storage room, in their house, bottom line. And if they can't get it there, what does most every community have? A dollar store. So they got to be able to get it to the dollar store or a Walmart. So it has to be very accessible to these students. What's going to hurt, the group of students that's going to hurt the most is going to be at-risk students from this new virtual adventure. I know here in Kentucky, I will be visiting each Thursday in September some of the poorest communities in our state, mainly in Eastern Kentucky, to where these schools have went virtual, but kids don't have access to the internet. So they're not getting anything but a packet to do science in front of them, which is a big problem. Because we know, again, hands-on science like this is the best way to learn, where the kids can touch and feel and so on. So I'll be visiting those communities, giving away science kits to those communities, those kids. And I don't want to just go to one spot, because if I just go to one spot, then we know that the middle class and the upper class kids have transportation to get there. The lower class kids do not, if you will. So I want to be able to take it to them, give it to them. And if they ask to do a quick science experiment, then we'll do a quick science experiment safely with your mask on, with your gloves on, keeping 6 feet away. You can do science 6 feet away. That's not a problem at all. But what I have to do is end up taking science to the house, to the home overall. And there's a lot of communities, even here in Lexington, the second largest city in Kentucky, there are spot communities in the city that do not have internet access. So it's not just a rural community thing, it is a national thing. It's a big city thing as well, overall. So it's kind of key and important that we remember that the kids that are gonna hurt from this the most are those at-risk kids that don't have internet access, don't have a computer. And school districts can give kids computers all day long, but if they can't access the internet, it's kind of a waste of time overall. So keep that in mind as you are assigning these different cool science experiments, whether it be these or any free experiment that you get at hookedonscience.org or any content that you get at STEMfinity.com. Just make sure that it's ingredients from around the house. Remind the kids that it's okay to make a mistake. So in other words, if the experiment doesn't work, it's okay to keep trying, because most of the time it doesn't even work the first time. Sometimes it doesn't work the first time for me, a scientist. And help the parents understand that, hey, you don't have to be a scientist in order to get your kid excited about science. So I kind of focus on those 3 things when teaching virtually. Remind parents they don't have to be a scientist to do science. Everyday ingredients from around the house, and it's okay to make a mistake. Keep trying, keep trying, keep trying, keep trying, scientific method. So as Bill had mentioned, and as I'd mentioned earlier, I am a meteorologist by training. My first television weather job was in a place called Hopkinsville, Kentucky. For those of you not familiar with Kentucky, that would be west of Bowling Green, northwest of Nashville. Most everybody knows where Nashville is, and southeast of Paducah. That was in the late 90s. So I was doing TV for a long time until 2007, and I got tired of doing television weather and decided to start Hooked on Science, providing schools, homeschools, retirement centers. Yeah, when I first started doing this, I thought just kids, but then I would get calls from retirement centers to come in and do science with an older audience. So Hooked on Science has grew from anywhere from preschool to 110, doing mind-blowing science, and every single age group is awed, wowed if you do it just right. I am in a TV studio, so since we've been doing this COVID-19 thing, I have been doing more weather stuff. So each Sunday night, Monday night, Tuesday night, Wednesday night, I'm the chief meteorologist here in Lexington, Kentucky at WTVQ. It's an ABC affiliate. And then I fill in Evansville, Indiana as a meteorologist. I was just there this past Saturday overall. And then in between all of that, I'm doing virtual science programs and still some in science programs. I was just in northern portions of Indiana visiting and doing a professional development, kind of sort of with a bunch of kids in that area, with a library and some of the people that stuck around, all that good stuff. So more kids than anything, but there were some adults there and teachers in general. Then we did some science experiments just all over the state of Kentucky and everywhere. Let me show you the studio really fast that I met. We are in front of what we call the chroma key wall. This chroma key wall is very movable, so it's a very versatile set. It's a fairly new set, but you'll notice how I can move the chroma key wall. So you see meteorologists with weather graphics behind them. Typically, the weather graphics are behind me, superimposed by a computer. So they don't literally appear there. It's still green. So I see what you see right now. So how do I know where to point at? Let me kind of adjust the camera and zoom in just a little bit and so on. And I can show you some monitors. So if I go to the right here, and then I zoom in, there's a monitor right there. That monitor I look at. There's a monitor right there that I look at to point. That is the weather center over here that we put together all of our weather graphics. Right now, as you can see from the radar there, basically a lot of rain in the western part of the state with some showers and storms. So it'll zoom back out and kind of show you the rest of the studio here. Again, this is the main set where the news anchor set, all that good stuff. There's the cameras. Also, the camera actually turns into, there's a prompter there typically, right? In other words, that's what the news anchor reads. Well, that prompter actually gets switched to a monitor, so I can see exactly what is going on when it comes to the monitor and all that good stuff and what you see on TV. So do you have any questions about that before we move on to some mind-blowing science experiments? Because I'm sure you're tired of hearing me yak about television. Any questions popping up at the bottom? Nope, I don't see any at all down there. If you do have any questions at any time, feel free to let me know. By the way, the experiment guides Bill will be providing with his little presentation, but you can always go to hookedonscience.org and download these for free. Download these for free. Each week there's a different science experiment. It includes a video. It's for free, and it uses everyday ingredients from around the house. One of the first ones I noticed that was on that list was the egg drop. So let me move a few things out of the way here. And the egg drop teaches kids about force and motion. So everything I do today will be based on the next generation science standards. The next generation science standards create strong thinkers. The ingredients that I have here, this is a vase, but you could always use just a regular glass, okay? Notice it's filled almost half of the way, if not half of the way, with water. I have a pie pan, I have a toilet paper tube, and I have a raw egg. So those are all the ingredients that I have right there to do the science experiment. So at this point, let me think about it. Next generation science standards, kindergarten and third grade talk about pushes and pulls. So this is when we might teach these concepts. But you and I both know, if you're a teacher, most of the time in kindergarten through second grade, you're focused on what? Math and reading. So you'll integrate science in. So there's going to be a lot of times where that third grade, fourth grade, fifth grade teacher, depending on what year you're tested in science at your state level, and a lot of that has been put on hold because of COVID, but you'll get back to it, believe me. They're reteaching K through second concepts. So while I say you might learn about pushes and pulls in kindergarten, you may have to reintroduce that concept in third grade. So a push or a pull is a force. A push or a pull is a force. So by the time you're in third grade, you've mastered that. You know that some things are easy to push. This is easy to push because it's on wheels, obviously. It's going to be harder to push me than it is a preschooler with the same shoes and the same floor underneath us because one of us has more mass, and that's me. So more mass, more force. By the time you get to middle school, and there may be some middle school teachers out there, you've really mastered 3 laws of motion. First law, my egg. Let me go ahead and set this up for you. I'm going to place this right on top. Make sure it's all in the center, like that. This goes on top of that, and this goes on top of that. There we go. So that egg is going to stay there until something moves it. The egg stays there until something moves it. Once the egg is in motion, it keeps going until something stops it. First law of motion. Second law of motion is force equals mass times acceleration, more mass, more force. And then the third law, for every action, there's an opposite and equal reaction. Okay, you're like, I didn't know all of that. Do I need that to teach this? Not really. Where are you going to get it? Well, in the one-sheeter. When I say one-sheeter, every experiment guide has all of that information you need to know about teaching the science experiment. So in other words, you don't have to do a lot of research. I put everything on one sheet of paper, how to do it, the explanation, and all the science background, and the connection for the next generation science standards for free, for you and your family, for you and your teacher families, if you will. So how do I get that egg in here without ever touching the egg? Does anybody have a hypothesis? Let me see if there's any comments coming up here. Let's see. How about Deanna? What do you think? She's smiling. She's got the blue shirt on. Do you have a hypothesis, Deanna? If not, we can always look at some others there. Give me your hypothesis. I'm trying to get that egg inside of the container. What about Noelle? What do you think? Yeah, I'm picking you now. I'm going through all of these lists. Let's see. Marie, what do you think? Anybody have a hypothesis? Let me think. Noelle says. How do I get that egg inside of my glass of water? Actually, it's a vase, but a glass will work without touching the egg. Do you have a hypothesis? You know, it's great that kids can regurgitate a force is a push or a pull. First law of motion, an object at rest stays at rest until acted upon by an outside force. But can they apply it to the real world? Bill talked about that a little bit earlier. We want it to where kids can apply the science to the real world because the real world is oozing with science out there. Once they can apply it to the real world, they've mastered it. That's key. We do hands-on science. We sneak the science in while they're having fun. They remember it a lot better than just multiple choice tests and fill in the blank. Okay, I am going to apply a force to the pie pan. The pie pan. Apply a force to the pie pan. When I apply a force to the pie pan, that should make the pie pan move. That should make the toilet paper tube move. And the egg should resist the change. What do we call that? The tendency of an object to resist change. That is called inertia. And then gravity should pull it in. Okay? Should. Sometimes it doesn't work the first time, and we make a big, gigantic mess. It's never good, right? You do use raw eggs. Now, if you're working with preschoolers or kindergartners, they're going to want to hit it and just keep going. And guess what they're going to do? They're going to knock everything off the table. So if you're working with a smaller group of kids, you may want to hold the glass and then teach them that as soon as their hand hits the side of the pie pan, they've got to stop as soon as they feel it hit it. Because if they keep going, they're going to knock everything down. Notice how my egg is horizontal and not vertical. So not like that, but like this right here, okay? So you see how everything is set up there. I'm going to zoom in just a little bit closer because I want to make sure that you can see what happens here whenever I hit the side of this and see the egg kind of fall right in there. So you've got everything set up there. Can you all see that just a little bit better, I hope? We have the egg on top, the toilet paper tube, considering that everybody bought toilet paper at the beginning of this COVID-19 thing, have parents keep the toilet paper tubes. I think there's one company that makes them smell good now. I at least saw commercials, so you might get some smelling good toilet paper tubes overall. So there should be plenty of toilet paper tubes out there. Okay, so apply a force, a push or a pull. As soon as I hit this, this and this should go that direction. Gravity should take over and pull that into the container of water. Okay, are you ready for this? Thumbs up. 3, 2, and yes, it went right in. Pretty cool. So we've just taught kids about pushes and pulls. We've taught kids about laws of motion, all that fun stuff. As we have done a pretty cool science experiment, I'm going to zoom out just a little bit more and do it one more time, just in case if you missed it, just in case if it was too fast. And show you again, you have to apply a force. Once you apply the force, the pie pan and the toilet paper tube go one way, and then the egg resists the change. We call that inertia, or the tendency of an object to resist change. We'll grab the egg out. I only went half of the way with water because I know that when I put my hand in there, the water is going to be displaced, and we'll go out of the top. Okay, put that on top. This on top of there, this on top of here. So we've got all the ingredients together there. Oops, you notice it's kind of off a little bit. It's important that everything is lined up straight. Doesn't mean the experiment won't work, but it will lessen your chances for it to work. Okay, so apply a force. Again, once I feel my hand hit the pie pan right there, I'm going to stop. 3, 2, and it goes in each time. Now, when I did a Today Show about a year ago for Spring Science, we did 5 of these, 5 toilet paper tubes, 5 eggs in one gigantic tray. When we hit it, all of the eggs went to the 5 cups, the tray and the toilet paper tubes went that direction. It's a pretty cool experiment to kind of see how that worked. And that did take practice, but with live television, sometimes it doesn't always work, and you have to make sure that you can explain why it didn't work and all that good stuff. Now, I saw some comments kind of pop up at the bottom. I can't see them because I'm far away. And when I turned 40, it seems that my arms got shorter, but here's the deal. Can't see them close up either. So did anyone have a quick question before I move on? I saw some things pop up at the bottom, but let's see, STEMulate training, yes, pretty cool. And so on. So, oh, no, sorry. Meant to ask if, okay, continue typing out your question. What happens if you use boiled eggs? Boiled eggs. Boiled eggs will work, and you won't have to worry about as much of a mess, especially with kids. I've also used the fake eggs that you can buy at Hobby Lobby, because you know, with the younger audience, preschool, kindergarten, you don't want eggs everywhere. You don't want kids playing with raw eggs, all that good stuff. So a hard-boiled egg would work. I've never tried it, but there should be no reason. There's no science behind why it wouldn't work. The plastic eggs, I do know that if you use those, even the Easter eggs, you could probably use those. You have to hit it a little harder. You have to hit it with more force. So instead of me just hitting it like that, I would have to whack it really hard like that. Otherwise, since it's so light, it has less mass, it's going to kind of go with it, versus because more mass, more force, more inertia. Bottom line is, I've learned with the empty eggs is what I'm trying to say. You have to hit a little bit harder. Okay, cool. Let's move on to the next one, which I think you're going to like as well. We are at about 1/4 so I want to make sure we try to get everything in here. The next one that I want to try with you has to do with vinegar, a giant jar or container, baking soda, and this right here. So this here is a balloon that I have filled up with baking soda. How did I fill it up with baking soda? Well, you could always use a funnel, or I just stretch it out and then have a kid pour it in there. Okay, I had my kid do it earlier. So I've got my baking soda in here. This teaches matter. So 2nd graders and 5th graders are mastering matter. Matter is anything that takes up space and has mass. Matter can exist in 5 states, but in elementary school we focus on 3: solid, liquid, gas. We know that matter can go from one state to the next, and mainly it depends on the state because of temperature. We know we can boil water and it goes from a liquid to a gas. We can freeze water. It goes from a liquid to a solid. And we can thaw it, if you will. It can go from a solid to a liquid whenever we add temperature to it. Matter is made of small pieces. That's really key, especially by the 5th grade. So this desk, this balloon made of small pieces. For example, if you take and put together some atoms, you will get a molecule. So for example, H2O, 2 hydrogen, 1 oxygen, that gives you water. So it's made of smaller pieces, water is. I'm gonna take my vinegar. We know about vinegar, you might use it in your salad. You might use it to get rid of hiccups. You might use it, I don't know. I'm sure there's lots of folklore about what it'll do and what it won't do. So what I'm gonna do is pour some of my vinegar inside of the container here, just like this. Now, I'm gonna smell like vinegar all day long. I have went to the extreme, and you know those big giant water jugs you can get at the front of Walmart or Kmart or Target. Wait a minute, Kmart doesn't exist anymore. Target, all those places, Myers, the giant jugs. And then I have poured a whole gallon of vinegar in, and then you know those punch balloons? Put the punch balloon on top of that. So the bigger demonstration, if you will. So I've got that much vinegar. Is that enough? Or what do you think? Should I add more? It's your experiment. You tell me. Anybody want to add more? Let's see. I'm looking for comments at the bottom. I mean, do we want an explosion? Do you want me covered in vinegar and baking soda? That'd be funny, right? I have caught on fire on TV before, by the way. Pour a little bit more. Okay. Next, what I'm going to do is take my green balloon. I might smell it. Remember, when we are talking about matter, we typically use our 5 senses to talk about matter. So, in other words, I might smell it correctly, like this. I wouldn't drink it because in science class we don't drink. Listen to it. Does it sound unique? Let's see, what am I missing out? Touch it. Touch, smell, taste, look at it, listen to it, so on. Okay, what I'm going to do next is take this and put it on top. Okay, and then I'm going to zoom in a little closer because I want to make sure, you know, we're doing this virtually. It's not like you can get up and come look at it. And I'm going to make sure you can see it just a little bit better. There we go. And we're going to mix these 2 ingredients together. So by the time you get to 5th grade, you have mastered that when you mix 2 ingredients together, sometimes you can get something new. We call that a chemical reaction. A chemical reaction. So I'm going to mix together vinegar and baking soda. Chemical reaction when you get something new. Physical reaction when I rip paper, that's a physical reaction, okay? But if I burn the paper, I get something new called ashes. So those ashes proves that it's a chemical reaction. I'm going to mix the ingredients together, and I can prove that I'm getting something new right here because, oh no, because it is expanding, it's getting bigger. And it wasn't before, oh goodness. That's a lot of gas. This is carbon dioxide gas. This explodes in my face. I've got my glasses on. And that's happened before too, by the way. There we go, it worked. But you can, oh, it's cold. By the way, I feel the sides of the jar, it's cold. Why is it cold? Because in science, when a chemical reaction happens and we get something new, that is called an endothermic reaction, an endothermic reaction. So the opposite of an endothermic reaction is an exothermic reaction. It gives off heat. So endothermic reaction gets cold, and exothermic, I'm being covered up by the balloon. Can you see me now? An endothermic reaction gets cold, an exothermic reaction gets hot. That was a chemical reaction. We got something new, a gas, when we mix together the ingredients. That gas, carbon dioxide gas that filled up the balloon. We can let it go. And it will go all over the place, everywhere, all over my phone. I smell like delicious vinegar now. Okay, any questions about that one before we move on? And we'll save more questions at the very end as well. Questions that you might have, but if you have one that really you want to ask right now, I'll be keeping an eye out at the bottom of the screen there and get a little bit closer, but not too close. The next one. Oh, got less than 10 minutes. We better get through this. It's not sunny here. in Lexington, Kentucky. It's cloudy. I'm looking at the radar now. Actually, I'll have one of my oldest kids go outside and check to see if it's sunny. Take that right there. You won't be able to get back into the building since we're at a TV station, and we try to keep interesting people away that want to come in and voice their opinion. So let me know if it's sunny outside. Sunny outside. Okay, so this next one has to do with this right here. Now, this is just a vase that I grabbed when my wife wasn't looking and got it from the living room, so hopefully we won't break it. And then I have a ping pong ball. You can use a Gatorade bottle for this. You can't use a regular water bottle, I'll be honest with you, because the water bottle is very flexible. You know, if you touch it, it squeezes in the sides. But a Gatorade bottle, it won't do that. It won't squeeze in as much. It's a little more tough and rough. So a juice bottle, a Gatorade bottle will work perfect for this, okay? I just use this vase. It looks a little prettier, so on, bottom line. So is it sunny outside, Ethan? No. So we won't be able to pop a balloon inside of a balloon because of that, but I'll show you how to set it up because all you need is ingredients from around the house to do it. I do need to overfill my vase here with water. Overfill my vase with water. So I'm going to use some of the egg water experiment, and I'm just going to keep pouring until it goes right over the top. Right over the top. Now, I do want to show you something, and this is very important. So let me zoom in just a little bit closer to see if you can see it. When you zoom in, and it may take a little bit, that's as close as I can get. Okay, but you'll notice at the very top, the water kind of goes over just a little bit. You see the little bubble? I guess that would be, there's concave and convex. So this will be convex. Concave goes in, convex is outward. So you'll notice how it's going outward just a little bit there. It's not in. That's key for this experiment. Next, I'm going to put the ping pong ball on top. See there? Move it around just a little bit. The next thing that I'm going to do is I'm going to pick this up and I'm going to turn it upside down. Ooh. Didn't work the first time. Let's try the second time. Pour more water on the inside. Do this over the couch. You know, I bet you what it is. There's baking soda pieces on this, and that's not a good thing. From when I had the baking soda on my hands earlier. Okay, put that on there. Now we'll see if it works. You got to do this slowly, by the way. Slow. Oops. I'll get to the camera view. Sorry. And I've turned it upside down. Now, it does take some patience. Here's my question to you. Why is it doing that? It shouldn't be doing that, should it? Well, the science is simple. We know gravity is pulling down on the ball, right? Not only is gravity pulling down, but we also have another force acting on it. Air is pushing against the ping pong ball. Not to mention that there's a little suction between the lip of the vase as well as the ball, the sphere. With that in mind, and air is pushing harder than gravity is pulling down, it doesn't come out. Slowly go back the other way. Slowly go back the other way. I will tell you it doesn't leak that much with the Gatorade bottle. It doesn't leak that much with the Gatorade bottle, but it does leak a little bit with this one. And you're like, you glued it on there, dude, when I wasn't looking. No, didn't glue it at all. So it's always fun. I would have a bucket of some kind of tray underneath so that kids don't make too much of a mess whenever they do that science experiment, because they will, and some of them will purposely squeeze the water bottle or the Gatorade bottle to make a big mess. I mean, that's what it is. The fun part about being a kid, making messes, right? And doing the opposite of what your teacher's telling you to do. So that one's pretty cool. Let's move to the next one. A bag of water. Uh-oh, we're running out of time. Bag of water, right here. The bag is made of small pieces. Smallest unit of matter is an atom. You put together atoms, you get molecules. So this bag, small pieces. Those small pieces, we want them to hold hands tightly around the pencils. Notice that I have some sharp pencils. So I'm going to take and jab the bag filled full of water with pencils. Will it work? Let's get closer. Push it through, and it does. See there? Science here, simple again, smaller pieces holding hands tightly around the pencil. There's 2. My computer's nearby, I better be careful. 3, if you suddenly lose my connection, it's because a bag of water fell on my computer. And 4. No leaking taking place. I typically use one of those gigantic bags. Let me grab one for you and I'll show you what I'm talking about when I say gigantic bags. Well, I didn't bring one into the building with me, but you know, in the linen aisle, you can get the big bags that you can store your clothes in, or for that matter, blankets in, and then you push the air out and zip it at the top. It's really huge. Use that and gigantic skewers, or I purchased a gigantic pencil that's about the size of a yardstick that's very sharp that I push through it. So while this is fun on a smaller level and it encourages kids to think, you can do one on a bigger scale as well. Okay, I told you it was cloudy outside and the sun for this last experiment was key, but I will at least show you how to do it so that you can get the ingredients and try that one at home. So what you need is a dark colored balloon and a clear balloon. You can get all these at your party store. So I have a dark colored balloon, I have a clear balloon, and I have a magnifying glass. All this important. So before I do this, I'm going to stretch out the balloons because you're going to have to inflate the dark colored balloon inside of the clear balloon. You know, on a hot summer day, a meteorologist will tell you, do not wear dark colored clothing. Don't wear a burgundy shirt. Don't wear a dark orange shirt. Don't wear a blue or a navy shirt, because you're going to get a lot hotter thanks to the sun attracting to those colors. That's why sports teams, you know, not all of them abide by this, but most of them will have a light colored uniform. You see how I did that? I was talking to you, blabbing, but I put the dark colored balloon inside of the light colored balloon, the clear balloon. I'm going to inflate it. Okay, as my eyeballs come out. And it pops. But you get the point. You got to inflate the dark colored balloon and the clear balloon. We try to stay away from balloons during this very COVID active time. That one's okay because that balloon doesn't typically pop like that. And if it does, it's popping in your own face. You inflate the balloon, and then you tie it and put it inside, and then you inflate the clear balloon and let the balloon bounce around, the dark colored balloon bounce around on the inside. Once you've done that, you take the magnifying glass outside, you hold the balloon in your arm like a little baby, and then you put a beam of light on the dark colored balloon that absorbs the light, and you pop the dark colored balloon inside of the clear balloon. Pretty cool, right? And it's all about heat transfer. So heat can be transferred one of 3 ways: conduction, convection, radiation. And of course, we are using the energy from the sun. I can go outside and know that I don't have to touch the sun to know it's hot because energy from the sun is being transferred to me through radiation. Transformation of energy, we talked about that a little bit there as well. Okay, so those are some cool experiments. Sorry we didn't get to do the last one because it's cloudy here and the sun is important. But the other's pretty cool, amazing. You can get all these experiment guides there at the Facebook, there at the hookedonscience.org. Speaking of Facebook and Instagram, don't forget to go like those pages. Just look for Hooked on Science. I did post some pictures from the training today as well. Just look for Hooked on Science on Facebook. If you do type in Hooked on Science, it's going to pull up Jason Lindsey, aka Mr. Science with Hooked on Science. Go like those pages. I always post resources like this often and just fun stuff all the time that has to do with family science, teaching, connecting science to the real world. Do you have any questions? Any preguntas? Let's see. Oh, yes, as Tia had posted there's the website, hookedonscience.org. Do you have any questions for me about the experiments that we did, as we are now at 2:02? Any questions at all? Awesome, thank you so much, Stephen, is that right? Yes. Any questions about anything? So I have a question for you. What is your favorite experiment that we did today? Was it knocking the egg into the water? Was it blowing up a balloon with vinegar and baking soda? Was it turning the vase upside down with the ping pong ball in it? Or was it jabbing the pencils through the bag of water? So raise your hand up if you like this one the best. Raise your hand if you like turning the vase upside down with the ping pong ball. Raise your hand if you like knocking the egg into the water. Raise your hand if you like inflating the balloon with the gas that we created by mixing those ingredients together. Cool. Let's see. Egg in the water, someone said. That was a good one. That was a fun one. This week's experiment of the week is this one, by the way. So it tells you all the ingredients that you need there at the website as well. Okay. Thank you for having me. I hope you and your family and all of your students stay healthy and well as we continue to battle COVID-19. If you ever have any questions about anything, feel free to send me an email or contact me on Facebook, and I'll do the best that I can to help you out in any form or fashion. When you go to hookedonscience.org, you'll notice something popular, and that is the virtual family science night that we do via Zoom or Google Meet or Skype or whatever it is. I basically send you a bunch of bags, and the families, you get them to your families, and we do a virtual family science night. Very popular with a bunch of schools right now overall.
Well, what we can do, Jason, is I can actually take everybody to your website.
Cool. Thank you so much.
All right, thanks, Jason. But I'm gonna take everybody to hookedonscience.org, and that way you can see it firsthand. So, Jason, if you want to follow along here.
Yes, sir.
Let's see here. Let me share my screen and Hooked on Science. All right. So hope everybody can see this here. Let's see. Minimize that. So you can see on here you have Science on the Go, and so the video I tried to show you guys before is going to be right up here on top. This is a compilation of his different videos. You'll see within the website. Apologize, my internet speed. I'm at my office actually, which has been vacant for 6 months, and I think everything's slowed down over that time. But you'll see all the different videos in here. This is a Today Show favorites that I was trying to show earlier, so you can find that right there. So it's Science on the Go. Make sure you get to that. Also, you'll see experiment archive, and so we did 4 or 5 different experiments today, and but if you're looking for additional activities, you can go there. You'll see different experiments of the week, which you just mentioned, the ping pong ball sticking to the water. The activity is the experiment of the week, and you'll see some of the things that he's done around, and of course different sponsors and TV shows that he's been on. Yeah, so make sure you get into Hooked on Science. So go to Experiment Archive and the Science on the Go for additional things. So within here, see a lot of physical science, life science, earth science, and then each of the activities that go with it. So make sure you get a chance to go there. And Jason, did you want to share any more about this page? I think you mentioned there's the virtually science.
Oh yes, if you go to school programs right there, it's to the right of Experiment Archive. The experiment program, the school programs kind of go over just all of that if you scroll down there, and that includes everything from the Healthy at School virtual science programs, everything from the Hooked on Science lab book to the Hooked on Science in a box to the virtual family science night. All of that's right there. And more for those that are doing in person. A lot of rural communities to where COVID is not a big, COVID's big everywhere, but I'm just saying there's more cases in areas that are not as rural than there is areas that are rural. Some of them have evolved back to in-person classes, in-person science programs, but you still have to be careful with making sure you're wearing your mask and you're not gathering an X number of students in one big audience. So I don't think we'll get back to assembly science programs anywhere in America until the fall of 2021 or until the vaccine has been established.
Yeah. Yep. And so there's a lot of resources here that are inexpensive, or virtual offerings you can do at home with your children or with your students. So definitely encourage you guys to check out hookedonscience.org when you get a chance. All right, well, thank you, Jason. Then what I'm gonna do real quick too, is there any questions about for Jason Lindsey? Let me go back to the chat bar. I think we're all good on chat. Looks like no questions right now. So, okay. Well, I'm going to continue on, give you guys a little explanation of STEMfinity on the website, as it is a lot easier to browse once I give you this description. But when you go to STEMfinity.com, you'll see it's broken out in these different categories. So whether it's technology, flight simulators, robotics, audio, video equipment, etc., engineering, math, robotics, STEAM at home, which are I'll go to a little bit later on, but there's a lot of inexpensive STEAM resources for individual use. We have makerspace solutions, virtual programs from pre-K to high school, summer programs, different bundles, and then the and beyond covers everything from like the STEM 101, which is what Jason Lindsey provides. Before it would be on site, and we're working through different virtual options of the STEM 101. You'll see furniture and storage, etc. But like I mentioned before, there's 4 main hurdles we're trying to eliminate for you. The first hurdle is a fear of teaching STEM. And so we've created these free STEM resources, which is down here. And when you dive into it, you'll see it's broken out by STEM, actions and lesson plans, coding and programming, STEM careers, STEM competitions, all free STEM resources, and women in STEM. And so you'll see the whole range of things, and I'm sure you recognize many of those. So you have Hooked on Science right here, but Khan Academy, a lot of different NASA resources are within here. And so we are once again vetting those out, but these are partners in the sense that they have a lot of free STEM or science activities within their website. And so a great way to kind of consolidate in one spot. So we encourage you to start here if you're new to STEM or STEAM, and to get things started for your program, and also to complement what you're already doing with your students. The second hurdle was funding, and so we've actually put together a STEM grant page. We have verbiage from past successful grant applications that we can share as well. And so you see it's broken up by state. There's federal grants available. We have national private foundations list here as well. And we have, like I said, the verbiage to go into the grant. So it's somewhat a win-win, where we help you write the grant, and then if it's awarded, you'd be able to shop through our 12,000 different resources with us and find things to suit your students. And that's the third hurdle, which is, let's say you're given the 21st Century Grant, you're told you need to teach STEM or STEAM for your students during the summer. What we've done is vetted out these resources. So right now we have about 130 different brands that we work with. So everything from Ozobot Sphero, Lego Education, Connects Education, etc. So there's around 125, 130 different brands we work with. You'll see different bundles like this Lego Education We Do 2.0 camp bundle, which is intended for after school and summer camp use, which comes with 10 of these sets. This is the set we're going to be giving away, which is the Lego Education Spike Prime set. So I'm going to dive into here. Like I said, this one is more for middle school. There's over 40 hours of lessons to go along with it. And when you get a chance, I encourage you guys to come check out the video and learn more about it. But there's everything from different apps, building instructions, STEAM at home resources to help you out. There's now a whole ESL curriculum to go with things as well that we have different bundles for with Lego Education and their sets. So keep in mind, they are sponsoring this webinar, and so I encourage you guys to check out their different resources. And they've put together a whole continuum from pre-K to high school. So I'm sure you're familiar with just a typical Lego bricks, which is going to be early on in the kindergarten range. But before that, there's the Duplo, which are larger bricks, and then advances into the the regular brick size. A lot of your simple machines. Then a primary, which is going to be more of the We Do set. And then the new Spike Prime is going to work for the middle school students. And then the Lego Mindstorms EV3 is going to be more high school focused resources. So but as you go through here, you'll see science. We have everything from online STEM Academy, School Closure STEM Kit, virtual resources there. You know, like this one, this is a whole STEM pack. So whether it's individual sets, like $9 learning wrap-up set, to you know, very large bundles, we can work within all that. So the EV3 homeschool bundle here, Wonder Workshop home learning bundle here. So a lot of tools and resources, but once again, we have former educators in our office that can help navigate this website for you and align things based on your needs. So you're not having to spend all your time shopping through the 12,000 products that are stored within here. So keep that in mind. And then the fourth hurdle is, once you have everything, what are you going to do with it? So that's where Jason helps out with our professional development. This is back when we were able to offer on-site training. So we're working on a virtual version of this right now, but you'll see some of the different videos and so on of what Jason's done in the past, and some testimonials from the different assemblies and workshops he's done. So like I said, we'll have a virtual STEM 101 available here very, very soon. So there's the 4 hurdles that we mainly help overcome. Look at the time. We still have a few more minutes here. But one thing I want to kind of point out are some of the core areas, like the STEAM at home. Because a lot of students are still learning from home. It's going to start with the most expensive sets and then go down in price. So don't get the sticker shock at first. But you can go price low to high, or vice versa, and shop that way, or by different categories. So there's a lot of inexpensive tools to start with, for $10, $25 or so per student, and they can expand up from there. So whether it's flight, natural resources, soil, whole range of different hands-on activities to get your students working through and understanding these STEAM concepts. And then we also do a lot of the virtual programs. So these are going to be a blended approach, like many of you had mentioned. So like this right here is actually a virtual robotics programming, where you can, instead of having a virtual or a real Lego set or real robot, you're able to program a virtual version of that. And then with AI, there's some different Tectera courses you can have for K through or pre-K through 12. So a lot of virtual programs there. And then a lot of you, I know, still were able to offer summer programs, just a different variation of it. But many of these are camp bundles. So they include the curriculum and content and everything for you. So like here, the kids create their own record label. Let's see here. We have the kids build their own BMX bikes. I'm sure many of you obviously are from California. And so the Science Action Club is through the California Academy of Sciences. So we work with them on kitting these different sets available here. So a lot of bundles and resources there. And one I want to highlight, though, like I mentioned before, is the Lego Education resources. And let me go to that page. So let's click on Lego Education. And you'll see, once again, it starts with the most expensive sets and goes down. There is now the SEL packages for the younger students. So, this is a great way to combine.
Anything.
What's that? Hopefully this is working for you. Can you hear me okay? Okay. Yeah, so those are the the core parts of the website. And I'm gonna go back. Let's see here, stop sharing. And do this real quick. And hopefully everyone can still hear me okay. But these are the activities that Jason went through and did. So we have the balloon blow up, using, you can see the different ingredients here, the baking soda and vinegar, next generation science standards, connection, etc. So it has all those for each of the activities. And on his website too, hookedonscience.org, you'll see a lot of more details of each of these. And leak-proof bag are all in there, and then pop balloon inside a balloon. So a lot of the questions you guys had in the chat they'll be answered within here. So typically you would tie them both off, so then they don't leak air inside the other. But yes, you'll see all that detailed there. I just walked through some of the core areas of our website, One Stop STEM Shop, all different brands, professional development, etc. There's custom STEM solutions, summer camps, after school, STEM 101, etc. So meant to be your one-stop STEM shop. And then Jason and I have all of our contact information here. So I encourage you guys to either jot that down, and we have a bunch of different flyers we can share with you at the end of this. We have the PowerPoint we can share with you. But ultimately, during these challenging times, we want to make sure that we're able to offer virtual and hands-on components for you to utilize. So just make sure that you reach out if there are questions or concerns, because we do want to make sure that as you go through and integrate, that it works out for you. So, but I know that there is an evaluation form that Tia mentioned that we need to go through and do here. Correct, Tia? So make sure you check out that. And we're always adding, updating, removing different resources. You can also shop by STEM brand. For any discounts and special offers, you can find it right here. And then we have a lot of resources under $100, book bundles. We've tried to think of everything that could possibly in the STEAM space, have it all in one location. And this makerspace. And then we also have drones that are programmable, like this one. So you can actually program it and fly it, but also transforms into a boat and a hovercraft as well. This is cardboard construction. And so you can go through and build really large activities like this, or smaller. So some cool things just using cardboard. And these are classroom packs, but we do have smaller bundles as well. It's Make Do is the name of it. But there's some different resources down here. So the individual student set is around $12.50, and it includes the different screws and saws and so on to build with cardboard. So this has been a very popular resource just because most students do have access to cardboard, and they can easily go through and work with their students on that. Real quick though, we're about 10 minutes out from finishing. I want to go through, have about 5 minutes of Q&A. So let me stop sharing my screen. So on the chat bar, let's see if there's any questions for me. So, yeah, we have the whole continuum with Lego education. Yep, just regulars. So regular Legos, yes, Lego education. All right, so quite a few you do. Yeah, so just from individual Lego bricks, with 6 2x4 Lego bricks, I think there was something like 64 million different ways that you can connect 6 Lego bricks together. So there's, if you think of the creativity and the imagination on all the different ways you can construct and build with Lego, there is, pretty much opportunities are endless for your students to utilize those. Also, I have, I guess, some of these set up in my office, or I guess it's kind of a little conference room. Hopefully you guys can see it okay. So there's Spike Prime. We have the Lego Education We Do. We have the EV3 set right here. The Coding Express. We have, I'm not sure how you can see it okay, but Magformers, Kano Computer Coding Kit, Makey, Book of Ideas, the drone, the Make Do set down here. Got our cool robots over here. We mentioned Dash and Dot, 3D printers, etc. So a whole range of tools that we offer, and we can do kind of the initial training for you guys to get started as well. So a lot of things to work with. Yeah, so go ahead and I know Stiana just put the evaluation form on here, and looks like you receive a Google folder, toolkit with the training materials, resources, and certificate of attendance. Let's see, so you had it coming up before, okay. as I know there are companies that do the service, provide the service for you guys to run your after school programs. These are meant to be out of the box for your staff to run. So it has all the curriculum and training manuals for your team to do that. Yeah, if you want to go ahead and do the evaluation form, fill that out, and then we'll be announcing via email on October 1st the winners for the giveaways. So we have Jason Lindsey's lab book, and then we have the Spike Prime set here too. We'll be sending out to you if you do win. So 2 different winners we'll announce, and like I said, you can enter in now, and then also there'll be some different ways where you can enter again and increase your odds later on. So make sure you go ahead and do that. But any other questions for me right now? Might be able to finish up here a little bit early. Apologize for not filling the full time. But any questions about material, solutions, anything like that we can help you with?